Good morning and welcome back. So this is the last part of model question paper number 1 discussion. So here I have question number 9C. Already 9A and B I discussed in the previous video. Because it was taking a lot of time, so I thought the video will be very lengthy, so I reduced it and I could not discuss this question in the previous video. So now I am continuing with the remaining part of module 5. So here is the question. The question actually it is a lab component. It is not connected to animation, either animation or statistical physics. ನೋಡಿ ಇಲ್ಲೇ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ. In an optical fiber experiment, laser light propagating through the optical fiber of length 1.5 meter made a spot diameter of 8 mm on the screen. You all might have done optical fiber experiment in your physics lab. See, this is the new type. This time they have introduced a lab component in the question paper. Earlier in the old scheme there was no lab component in the question paper. Lab exam was separately conducted, but lab exams have been removed, so lab components are included. Already I explained one such type of question in laser chapter. Laser diffraction ge connect agiro tara I explained one question. Now it is optical fiber related. Please go through your lab manual given by your teachers in the physics lab. There you have equations. By and large almost all the colleges will be following the same equations for optical fiber, laser or magnetic field experiment or the LCR experiment. Okay, so such type of experiments where the equations are common, most likely questions will appear on such type of experiments only. This is my personal opinion. Hope so. It will be like that only. Well, let us proceed further. The distance between the end of the optical fiber cable and the screen is 0.031 meter. So calculate the angle of contact, that is angle of acceptance, and numerical aperture of the given optical fiber. So the equation is theta naught is equal to tan inverse of D divided by 2L. Here D corresponds to diameter of the circular spot. See, when in optical fiber you will get what is circular spot. On the graph sheet you get a circle like this. It will be having certain diameter, that is D. Okay, and from the optical fiber to diameter length L. So L is given, D is given. Now we have to calculate theta naught. Substitute the values. How? Theta naught is equal to tan inverse of D value is 8 spot diameter 8 mm, 8 into 10 power minus 3 divided by 2 into L value is 0.031. So simplify this. So take calculator and do it. Just 1 minute. Tan inverse of 8 to the power of minus 3 divided by 2 into 0.031. Close the bracket, close the bracket. So it is 7.352. So angle is 7.352. Very small angle of acceptance. Next, numerical aperture. Numerical aperture is equal to sine of theta naught, that is sine of 7.352. So calculate. Just to take the sine of this, it comes out to be 0.13. Very small numerical aperture. Maximum value of numerical aperture is 1, minimum is 0. So what is the meaning of numerical aperture? It is nothing but light gathering capacity of the optical fiber. Okay, all these details you know in optical fiber. I think I explained all these things. Well, let us move on to the next question. Now we have questions on animation. Sketch and explain the motion graphs for linear ease in and ease out cases of animation. See, in linear motion we have what is called uniform motion. Uniform motion means acceleration is 0, okay, but the body is moving with constant velocity. If a body moves with constant velocity, animation is very simple. Framing is very simple. Equal distances in equal intervals of time. Okay, so give the spacing uniformly. That is what this sentence means. In linear motion, if the body travels without acceleration, then it is uniform motion. The net force acting on the body is 0 and the time interval, distance traveled will be same. hence the timing is very easy. If the speed is less, spacing between the frame is less. If the speed is more, spacing is also more. So this type of framing we have to do. So see, look at the object distance, the spacing is same, equal spacing. Suppose the speed is less, the spacing is also less. If the speed is more, spacing is also more. This is the animation for uniform motion. Now slow out. Slow out is the process in which the body is speeding up from a still position. Its speed keeps on increasing, the accelerated motion. Slow in means decelerated motion. The body is getting ready to stop. So getting ready to accelerate, getting ready to speed up is slow out. Getting ready to slow down is called slow in. Slow out is also called as ease out. Slow down is also called as ease in. Okay, slow out definition. Slow out is a process in which body is speeding up from a still position. To create slow out, you should have more number of frames in the beginning. So spacing between the frames must be very less so that more number of frames. Gradually the spacing increases. So to create slow out, we need to place the frames close together and then move them apart gradually. Move them apart. Initially more number of frames, amele gradual agi decrease madbeku. Now coming to slow in. Slow in, as I told just now, is also called as slow ease in. Ease in is a process in which the body is preparing to stop. Andre retard aagta ide, decelerate aagta ide anta artha. It is created by how? To create the slow in, what we have to do? We need to gradually place the frames closer together at the end of the animation. See, slow out is in the beginning of the animation. Slow in is at the end of the animation. Look at this diagram. Initially I have more number of frames, gradually the spacing decreases, so this is slow out. Later on the object is getting ready to stop, therefore the spacing keeps on decreasing. So this portion is slow in portion, this is this portion is slow out portion, this is slow in portion. I have given all the details in my videos also. Please watch the animation videos once again for the better clarity. Now comes probability of proton decay. Sorry, already some matter is displayed there. Okay, I forgot to animate it. Well, anyway, discuss the modeling of the probability for proton decay. This is using Poisson's distribution. Dear students, even this proton decay modeling also I have explained in detail, but here for the sake of writing the answer, whatever is required, that much only I will explain. See, it is like this. Proton decay is a theoretical prediction in which proton decays into two particles, namely pion and positron, with mean life of 10 power 33 years. Actually, some selection rules, some conservation rules forbid proton decay to happen. And according to certain laws of conservation, proton decay is not possible. But still, across the globe, experiments are going on. People are trying to find out, is there any proton decay? Even today, not even a single proton decay has been discovered, but still experiments are conducted across the globe, including India. One such famous experiment is the experiment conducted and going on even today in Japan. It is called SK experiment or Super K experiment. In this Super K experiment, they have used 50,000 tons of pure water. 50,000 tons of pure water consists of 7 into 10 power 33 protons. Okay, and the entire lab where the experiment is conducted is covered. 40% of the entire lab, not entire lab, 40% of the lab is covered by detectors. If at all any proton decays, the detector will detect. Okay, so that is the intention behind covering the 40%. They could have covered it 100%. Since the plant is too big in size, they covered it only 40%. Anyway, Poisson's distribution formula is there to find out the probability of decay. If at all it is happening, 40% is sufficient. So 40% detectors are covering the entire project site. Okay, now according to decay law, n is equal to n naught into e to the power of minus lambda t. Dear students, this lambda is actually decay constant. We have one more lambda in Poisson's distribution, that is different from this lambda. Lambda is equal to reciprocal of mean life, that is 1 by tau. Tau is 10 power 33, lambda is therefore very small, 10 power minus 33. Okay, anyway, explain the terms. N naught is the initial number of protons, that is nothing but 7 into 10 power 33. T is time interval during which n number of atoms remaining and n naught minus n are decayed. If at all there is any decay ಆದರೆ ಎಷ್ಟು decay ಆಗುತ್ತೆ? T second ಅಲ್ಲಿ, T minutes ಅಲ್ಲಿ, or it can be T hours or T decades, something like that. So T is the time, n naught is the initial number, n is the number remaining after T hours, after T years. So let us say with me I have 1000 atoms today. After 1 year, I have 900 atoms. How many have been decayed? How many have been destroyed? It is 1000 minus 900. That is 100 have been decayed. That is the meaning. I hope you know all these details. You studied these things in PUC. Anyway, I have explained it here. N naught is number of atoms initially. That is 7 into 10 power 23. And N is the number of atoms remain after T years. Lambda is the decay constant. Okay. And then it is 10 to the power of minus 33, 1 by tau. It is not same as the lambda what we have in Poisson's formula. Okay, now as I told, lambda is very small. We can approximate e to the power of minus lambda t to 1 minus lambda t, binomial expansion. So therefore, n is equal to n naught into e to the power of minus lambda t becomes 1 minus lambda t. Simplify and then rearrange, you get n naught minus n is equal to n naught into lambda t. Now put n naught is equal to so much, t is equal to 1 year, lambda is equal to so much, and simplify, you get n naught minus n is equal to 7. That means if at all protons are decaying in 1 year, 7 protons must decay. Okay, 7 protons must decay, and my chamber, means experimental chamber, is covered only 40%. Therefore, detectors cannot detect all 7 events, all 7 decays it will not detect, only 40% of the 7 it will detect. What is the 40% of 7? It is 2.8. So I take it as 3. That means in 1 year there will be 3 decays if at all. ಆಗೋದಾದರೆ 3 ಡಿಕೆಗಳನ್ನು ನನ್ನ ಕೌಂಟರು ಡಿಟೆಕ್ಟ್ ಮಾಡಬೇಕು. Means in Super K experiment site in Japan, they have to detect 3 counts in 1 year. Dear students, you believe it or not, this experiment started in 1996. Even today they have not detected even a single decay. ಅಂದ್ರೆ ಕೌಂಟರ್ ಇವತ್ತಿನವರೆಗೂ ಒಂದೂ ಡಿಟೆಕ್ಟ್ ಮಾಡಿಲ್ಲ. ಅಂದ್ರೆ even after 27 years decay is 0. That means K is 0. In Poisson's formula, we have this equation: P of x equals K is equal to lambda to the power of K e to the power of minus lambda by K factorial. This is what the lambda is. You have to be very careful about this lambda and this lambda. This lambda is the probable happenings in that particular year, or average happening in that particular year. In 1 year, I expected 3 happenings, 3 events, 3 counts, 3 decays. Therefore, I take lambda as 3. But so far, how many decays have been detected? 0. That is K. So, by substituting lambda value and K value, I simplify. Probability of distribution is 0.05. That means very low probability I am getting. That indicates that the conclusion from the Poisson's distribution calculation, scientists at that site, Super K experiment sites in Japan, they have concluded that the mean life of proton should be at least 2 into 10 power 34 years. What does it mean? Actually, I was expecting some answer about whether decay is happening or not happening. But you are telling something totally different. What conclusion you are drawing? Please follow carefully. P equals 0.05 doesn't mean that there is no decay. I cannot arrive at that conclusion. Only thing I can say, protons I expected to decay in 10 to the power of 33 years. No, they are not decaying in 10 power 33 years. Their life is much more than 10 power 33 years. This type of conclusion I can draw. Much more than 10 power 33 years means it should be more than 10 power 33, that is 10 power 34. Sir, why only 34? It can be 35, it can be 36, like that. Yes, you are correct, but based on some other calculations, scientists have arrived at this conclusion that right now they assume that protons mean life is 2 into 10 power 34. Maybe after 10 more years, maybe after 20 more years, suppose if they don't detect the proton decay, even after 50 years, if they don't detect proton decay, then also they will not say protons never decay, protons decay agalla anta helodilla. Then they will change the time, and their life is not 10 power 33, not 10 power 34, still higher than 10 power 34. 34 ಗಿನ್ನ ಇನ್ನೂ ಜಾಸ್ತಿ ದಿವಸ ಅವು ಬದುಕುತ್ತವೆ. Still they have large amount of time, so they may decay ಅನ್ನೋ conclusion ಗೆ ಬರ್ತಾರೆ ಅಷ್ಟೇನೆ. So this is about proton decay. I have explained all these things in detail even in my video also. But for the sake of answer, you write only this much. That is enough. Well, with this, I come to the last question of this paper. This is one of the expected question from animation. A slowing in object in an animation has a first frame distance of 0.5 meter and the first slow in frame 0.35 meter. Calculate the base distance and the number of frames in sequence. Okay, dear students, in this problem we have to make use of two statements. One such statement is, one of the feature of odd rule is that the base distance is always equal to half of the difference between the two adjacent distances. So I repeat here, just I erase this. Okay, so you have to convert this statement into formula. What he is telling, base distance is equal to, see, this is the this is the slow in process. Here one object frame, next frame will be far away, next frame will be not that much far away, next frame will not be that much far away. That means the spacing keeps on decreasing when the vehicle or the object or the substance is slowing down. So frame gap is lesser and lesser. Now between first two frames the gap is, see, this is 0.5 and this is 3.5, this is 0.5, this is 0.35. Now the base distance is equal to 0.5 minus 0.35 divided by 2, that is the average of these two. So simplify, it is 0.5 minus 0.35 divided by 2 is 0.075. So base distance is 0.075 meter. So this is the base distance value, 0.075. Next statement, to find out or to figure out how many frames are there in the slow in process, divide the first distance ಅಂದ್ರೆ 0.5 ಅನ್ನ ಡಿವೈಡ್ ಮಾಡಬೇಕು by what? By base distance. Then you will get the number of frames, that is 0.5 divided by 0.075. Suppose if it comes out to be odd number, well and good, no problem. Suppose if it comes out to be a fraction, you approximate it to the nearest odd number. See, it is 0.5 divided by 0.075, it is 6.67. So F comes out to be 6.67. So I approximate it to 7. So there are totally 7 frames. So I hope you followed this. I hope you enjoyed this. I hope the whole discussion was little bit beneficial to you. If it is beneficial to you, my effort is fulfilled and my purpose is served. Dear students, feel free share your comments. If possible, I will try to solve one more question paper, or else otherwise I will share some important questions along with the answer. And this particular question paper's question and answer PDF link is available in the description box, so please download, practice. Okay, and also some students are asking me to do the question paper for electrical and electronic stream also. I will try, 99% I will do within 2 days. I will post that also. Keep supporting me and keep encouraging me. Subscribe to my channel and also press the like button and encourage me. Thank you, dear students. I wish you all the best. Do well in the exams. I hope you all will perform well and will come out with very good marks in engineering physics. Thank you very much.